Hello viewers, in today's session we are going to solve an important problem from limits, and here we have to evaluate this limit x tends to infinity, sine 2 over x plus cosine 2 over x raised to x, right? So to get the value of this limit, we'll first try to reduce this limit into this indeterminate form, that is 1 raised to infinity. So let us call the value of this limit as L, and in order to reduce this limit into this form, let us make this substitution, that is y is equal to 2 over x, because when x tends to infinity, then this y, it tends to 0, because when x tends to infinity, 1 over x or 2 over x tends to 0, right? So now this limit L can be written in terms of y. So we can now write limit y tends to 0, and we have sine y. For 2 over x we can write y, and then we have cos y, and for x we can now write here xy is equal to 2, so that y is x is equal to 2 over y. So here we have 2 over y. So now here we have two functions. The first one is sine y plus cosine y, and the second function is 2 over y. So let us assume this function as p of y. We have sine y plus cos y, and q of y is equal to 2 over y. So that this limit can now be written as limit y tends to 0, and here we have p of y raised to q of y, right? So now let us find out the individual limits of these two functions when y tends to 0. So limit uh, y tends to 0, p of y is given by limit y tends to 0, and here we have sine y plus cos y, and when y tends to 0, then we have here sine 0 plus cos 0, and sine 0 is 0, cos 0 is 1, so here we have a 1, and limit y tends to 0, q of y. So this is a limit y tends to 0, and here we have 2 over y. Now when y tends to 0, then 2 over y tends to infinity, right? So this limit, that is limit y tends to 0, p of y raised to q of y, it tends to that is 1 raised to infinity, which is an indeterminate form. So whenever we have this type of form, that is 1 raised to infinity, then the value of these type of limits can be directly written as e raised to limit y tends to 0, and here we have q of y, and then we multiply q of y by p of y minus 1. So here we have the direct result, right? So in general, we can say that if we have limit y tends to say a, and here we have p y raised to q of y, and if limit y tends to a, p of y tends to 1, and limit y tends to a, q of y tends to infinity, that is this limit tends to 1 raised to infinity, then the value of this type of limit can be written as limit, here we can write the exponential number e, then we have limit y tends to a, and then we write q of y times here we have a p of y minus 1. So now here the value of a is 0. So we can now write e raised to limit y tends to 0. Q of y is 2 over y, and then p of y is sine y plus cos y, and then we have minus 1. So we can now take this 2 in front of this limit notation. So we have 2 times limit y tends to 0, and we have sine y plus cos y minus 1 divided by y. So now we have to find out the value of this limit. So now to get the value of this limit, we can make use of L'Hopital's rule. Now here we have limit y tends to 0. So if we take y is equal to 0 in the numerator and denominator, then we have sine 0 plus cos 0 minus 1 over 0. Sine 0 is 0, cos 0 is 1, and we have here a 0 over 0 form, right? So using L'Hopital's rule, we can now differentiate the numerator and denominator. So the value of this limit can be written as e raised to 2 times limit y tends to 0, and we have the derivative of the numerator, and then we can now write here the derivative of denominator. So we have e raised to 2 times limit y tends to 0. The derivative of sine y is cos y, and here the derivative of cosine y is minus sine y. Then the derivative of 1 is 0, and here the derivative of y with respect to y is 1. So we have e raised to 2 times limit y tends to 0 cos y minus sine y. So now we have e raised to 2 times limit y tends to 0 cos y minus sine y. So here we can now take y is equal to 0. So we have cos 0 minus sine 0. So this is e raised to 2 times cos 0 is 1, sine 0 is 0. So this is e raised to 2 times 1, that is e square, right? So the value of this limit is equal to e square.